In the next section, the next chapter 4, we look at the ports in the PIC and what we can do to program using the ports on the PIC18. So we look at I/O port programming, and in section 2, the I/O bit manipulation, which is very important to understand at the assembly language level. We'll take a look at the ports, explain their roles, coding instructions, and bit accessibility. In the PIC18 family, there are many ports for I/O operations depending on which family member you choose. You can see that there are plenty of ports for I/O operations, a total of 33 pins set aside for the PIC18. If we take a look at the diagram, the rest of the pins are designated as VDD or VCC, VSS for ground, the oscillator ports 1 and 2, the clear, master clear or reset, and then another set of VDD and VSS. The number of ports in the PIC18 family varies depending on the number of pins on the chip. The 18-pin PIC18 has ports A and B only, while the 64-pin versions have ports A through F. And the 80-pin PIC18 has ports A through L, as shown in a diagram. To use any of these ports as an input or an output port, it must be programmed, as we'll explain throughout this section. Okay, each port has some other function associated with it, whether it's a digital converter, timers, interrupts, or serial COM ports. We can see then in this chart the layout of ports in the PIC18 family. Other ports such as ADCs, timers, and interrupts, and serial communication pins. We also have alternate functions for the PIC18 458 pins. We'll look at these alternatively in other figures. Okay, so you can see the 1220, the 2220, the 485, 458, and the 6525 and 8525s. How many ports are available depending on how many pins you have overall for the particular PIC that we're using. Okay, so we'll take a look at these as we start using the trainers. This will become particularly important for us to use and understand. Again, this shows the PIC18F 458 40-pin configuration. We'll be using the 4520 configuration.